Irodov problem number 1.134. A body of mass m is pushed with the initial velocity v0 up an inclined plane set at an angle alpha to the horizontal. The friction coefficient is equal to k. What distance will the body cover before it stops, and what work do the friction forces perform over this distance? Okay. Let's draw the diagram first. So there is an inclined plane. This makes an angle alpha with the horizontal. There is a small body of mass m. So it is pushed with initial velocity of v0. Okay. And there is some friction between this mass and the inclined plane. The friction coefficient is k. Question is to find out till what distance the body will go, let that distance be d, before it stops. Okay. And the second question is, in this displacement, what is the work done by friction forces? So let's look at the body. Let's do a quick free body diagram of the body. There is force due to gravity working downward. This is the surface of the inclined plane. There is a normal reaction working on the body from the plane. Velocity is that side, so friction force will be along the plane, downward direction. Okay, and there are no other forces. So obviously this angle is alpha. Okay, so let us apply work energy theorem. What does work energy theorem say? Work done by all forces is equal to the change in kinetic energy. Okay. So we can further write this as work done by friction force plus work done by this normal reaction plus work done by gravity force is equal to the change in kinetic energy. Now the change in kinetic energy is k final minus k initial. At this final state, the body stops. The k final is 0, and initial state the body was with velocity v0, so half m v0 square. So this is equals to minus half m v0 square. Okay. Now let's take a quick look at this side. Work done by friction we have to find out. Work done by normal reaction. So anytime displacement is in this direction, normal reaction is perpendicular to the displacement. So work done by normal reaction will always be 0. And then we have to find out work done by gravity. Okay. Okay. Now additionally, we know friction force is Kn, this is kinetic friction, so Kn. Normal reaction is mg cos alpha, so friction force is K mg cos alpha. Okay. If this distance is d, then what is this height? It is d sine alpha. D, this is alpha, sine alpha. Okay. So we can write work done by friction force K mg cos alpha in the negative opposite to the direction of displacement. So we have to put a minus minus kmg cos alpha, where did this come from? This is friction force, times d is the displacement. Okay. Now work done by gravity. So work done by gravity is same as the potential energy that is gained here in climbing this distance d sine alpha. So we can write, again this is negative because mg is acting downwards, d sine alpha is upwards. So mg times d sine alpha is equal to minus half m v0 square. Okay. So mm we can all cancel out both sides. So we can write 2k cos alpha times d plus 2kg cos alpha times d plus 2g d sine alpha is equal to v0 square. We take d common, 2kg cos alpha plus 2g sine alpha is equals to v0 square, or d is equal to v0 square by 2g 1 by k cos alpha plus sine alpha. Okay. So this is the value of d. Okay, next part of the question is work done by friction. Now work done by friction is this minus k mg cos alpha times d. So we can write minus k mg cos alpha times d is v0 square by 2g k cos alpha plus sine alpha. Gg we can cancel. So this is minus km v0 square by 2 cos alpha. If we divide numerator and denominator, becomes k plus tan alpha. So this is the work done by the friction forces.